Using the graph of function f of x shown below, answer the following questions. F of negative 9. Well, we're going to count the 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the point we're looking at is this point right here. And the y value that goes with that is 1. F of 0. Well, here's 0, because remember this is f of x, so x is 0, and what's the y value when x is 0? It is 0. F of 4, 1, 2, 3, 4, well, we're going to count up. 1, 2, 3, 4, 5, 6, 7, 8. Looking at this particular point right there. And F of 10. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looking at this point right here. And the y value that goes with 10 is 2. What values of x solve the equation f of x equals 0? Remember that f of x equals 0 is a horizontal line. It's the horizontal line y equals 0. So if we write that in here, I'm going to have to move it up a little bit. But if I scoot that up, what values? Well, what values? We've got a value here, which is 1, 2, 3, 4, 5, 6, 7, 8, negative 8. We also have a value here of 0. And we have a third value here at 1, 2, 3, 4, 5, 6. They don't have to be in the same order, but you do have to have all three of those values. It says, how many values solve the equation f of x equals 4? Well, when we come to this one again, remember f of x equals 4 is the same thing as y equals 4. We're not looking for the values. We want to know how many. So 1, 2, 3, 4. And I'll move this up here. Come on. There we go. And once we have that, what we're looking for is how many times does the equation cross there? Well, it crosses at this point and that point, which is 2 times. What is the y-intercept? Well, the y-intercept is 0, 0. It's been green, that point's been green, it's been purple, now I'm going to make it blue again. Using interval notation, what's the domain and the range of this function? Again, we have a starting point and we have an ending point on this one. And this is when I can use my highlighter to draw in a rectangle. We can only draw in the rectangle when we have a starting point and an ending point. I need to erase part of this here because the board seems to continually be disoriented, but we'll try it again. Better. So here's our rectangle. And the domain goes from the left side to the right side. And when we count over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. To the far right side, which is going to be at 10, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The range is the lowest value on the graph. 1, 2, 3, 4, 5, 6, 7. Negative 7. To the highest part of the rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we look at the relative minimum values. So the relative minimum is a low point on the graph. It also has to be at a valley. This point that I'm putting in red is a low point on the graph that's also a valley. It's got 2 sides to it. And that ordered pair is negative 1. We're Remember, ordered pairs have parentheses. It's -1 and let's see, 1, 2, 3, 4, 5, 6, 7, -7. And sorry, I need to put this over here because that was a relative minimum, not a relative maximum. So -1, -7 is one of the relative minimums. And actually, this pinkish purple point, which I'm now going to put in red, is also a relative minimum, which is 1, 2, 3, 4, 5, 6, 0. Those are low points, and again, they need to be at a valley. So here is one side, there's the other side. The relative maximum, well, the relative maximum is going to be at this point right there. And that value, that ordered pair, is 3 and 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the only relative maximum. It is at a peak here. But the thing about that relative maximum is not only is it a relative maximum, but it also happens to be the absolute maximum. It is the highest point on the graph. And the thing about the absolute maximums, or absolute minimum for that case, is that they don't have to be at a peak or a valley. They can be. It's just the highest point in the graph is the absolute maximum. The lowest point in the graph is the absolute minimum. And the absolute minimum in this particular case is the lowest point on the graph, which is here, which is -1 and 1, 2, 3, 4, 5, 6, 7, -7. So notice that they happen to be the relative values as well. And they can be. Lastly, all of the intervals where the function is increasing, all of the intervals where the function is decreasing. And if we start at the far left, because we're going to put this in order here, we're going down and down and down and down and down and down. And we're looking at the x values when we look at that. That's a decreasing. So we're going to be decreasing from -9, less than x, less than the x value of that pink point, which is -1. But once we get to that pink point, then we're going to start going up, 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 up. There's an increasing. We're looking at the x value. So it's going from the pink point, the x value of the pink point, to the x value of the purple point, which is 3. And then when we get to that purple point, we start going down and down and down and down. So I'll put a green point in there, but it's going to be decreasing again from 3, less than x, less than 1, 2, 3, 4, 5, 6, where that green point is. And we finish by going up, 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 up. That's going to be an increasing value. So this is going to be 6 is less than x is less than 10, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.